Hey everyone, and welcome. So today, we're going to tell a story. It's a story about what happens when our code, that beautiful, perfect code we spend hours on, suddenly finds itself in the spotlight, under pressure. It's all about unexpected slips, audience reactions, and how a truly great program can handle it all with style.
I mean, we've all been there, right? You're staring at your screen, 1 minute your program is running like a dream, and the next, bam, a crash report. It's got to be one of the biggest frustrations in programming. But what if we could actually prepare our code for the unexpected?
To really wrap our heads around this, let's use a little metaphor. Imagine your program isn't just a bunch of code. Instead, think of it as a performer up on a stage. It's got a script to follow, that's your algorithm, and it's got an audience to interact with, that's the user. So we're going to break this whole show down into 6 acts. First, we'll see our performer when everything's going perfectly. Then the inevitable slip-up, the exception. We'll look at the safety nets we can build to catch it. After that, we'll turn our attention to the audience, the user, and the events they create. We'll see how our performer should respond, and then we'll tie it all together to see why a great program needs to be a master of both. All right, so the curtain rises. Our program is just cruising. Every single line of code is executing exactly as planned. Every calculation is spot on. It is a flawless performance, moving from one instruction to the next without a single problem. It's perfect. Right up until the moment it isn't. And then it happens. Maybe it's an unexpected input, a file that's missing, or that classic division by zero. Our performer slips. This slip-up, this thing that just completely disrupts the normal flow of the show, in programming, that's what we call an exception. So to get a bit more formal, an exception is a runtime error. Now, this isn't you forgetting a semicolon. Your compiler would have caught that. No, this happens when the show is live. It's like the user typing in their name where you were expecting a number. It's an internal problem, a signal that something inside the program itself has gone seriously wrong. So what kind of slips are we talking about here? Well, you've got your numeric error, which is what happens when you try to say divide by zero, or a runtime error, like if the network connection suddenly drops. Storage error is a classic. Your program literally runs out of memory to use. And of course, the infamous constraint error. That's when you try to access an item in an array that just isn't there. These are the banana peels of the coding world. But hey, a little slip doesn't have to end the whole show, right? A real pro knows how to recover. And in programming, that recovery plan is our safety net. We call it exception handling. It's how we plan for failure so that the show can go on. And let's be clear, this is not just a nice to have. I mean, if you look at how programming languages are evaluated, reliability is absolutely critical. A program that crashes all the time is unreliable, and that poor reliability, it leads to huge costs in time, in money, and in your users' trust. So building that safety net, yeah, it's not optional. It's what professionals do. It's really cool to see how different languages go about building this safety net. The keywords are a little different. You see Ada uses raise and exception when, while C++ and Java use that throw with the try-catch block we all know, but the idea behind it is exactly the same. You need a way to signal that something's wrong, and you need a structure to catch and deal with it. Let's just zoom in on Java's model for a second. You take your risky code, the big complex stunt, and you wrap it in a try block. If something goes wrong, the program doesn't just crash. Instead, it jumps straight to the catch block. That's your pre-planned response. And then you have the finally block. Think of this as the stage crew. It doesn't matter if the stunt was a success or a total failure, the crew always comes out to clean up, closing files or releasing resources. It runs no matter what. Okay, but not every interruption is a mistake. Up until now, we've been talking about internal problems, right? The performer slipping on stage. But what happens when the audience starts interacting? When they applaud? That's a completely different kind of interruption. It's an external signal, and we call that an event. And that brings us to the audience, our user. They're not just sitting there watching, they're clicking buttons, typing in text boxes, moving the mouse around. Every one of these actions is an event, and they're an expected and honestly a vital part of the whole performance. So what is an event? Really, it's just a notification. It's the program getting a message that says, hey, the user just clicked the save button. Now, unlike an exception, an event is not an error. It's a signal the program is actually designed to listen for and respond to. It's the difference between an accidental trip and a planned dance move. And in a language like Java, these cues from the user get really specific. When someone checks a box, that fires an item event. Every single time they press a key, that's a key event. When you click into a search bar, that's a focus event, and as you type, that creates a text event. Our program is built to listen for all of these different signals from its audience. Okay, so the audience applauds. Our performer needs to know how to take a bow, right? That is event handling. It's the choreography we write ahead of time for how our program is supposed to react to all those user actions. The way this usually works, especially in languages like Java and C#, is through something called the event model. It's a pretty neat system. You have a source object, say a button, that creates an event when someone clicks it. And then you have a listener object that's just, well, listening for that specific signal. When the listener hears the event, it runs the code to handle it. It's a super organized way to manage all that audience interaction. So our performer can handle a stumble, and they know how to interact with the crowd. Now, for the grand finale, let's talk about why a truly great program has to be an expert at both. It's all about being ready for anything, the stuff you plan for and the stuff you don't. And this, right here, is the main takeaway. Exception handling is all about building a reliable program that doesn't just collapse when things go wrong. It's the bedrock of stability. Event handling is all about building an interactive program that feels alive and responsive to the user. You absolutely positively need both to create professional, user-friendly software. Period. So next time you sit down to code, think about your program like it's a performer heading out on stage. And ask yourself two things. Have I built its safety net? And have I taught it how to bow? Because a truly great performance depends on both. Thanks for joining me.